Welcome everyone to our channel S4 Education by Snehal. As we watch a movie, we need to follow the story from the beginning. So if we miss even one part, we may not understand what happens next. Our video series is similar. So before watching this video, make sure you have watched the previous ones. In this video, we will cover properties of arithmetic mean with proofs, merits and demerits of arithmetic mean, limitations of mean, and applications of it. Let us see one by one all the properties of mean. With property 1, which states that given mean and total number of observations small n, we can find sum of all observations by multiplying mean to n. If x is a variable which assumes n values x1, x2 till xn, then we know that arithmetic mean is equal to sum of all observations divided by total number of observations. Now by shifting small n to left hand side, the equation becomes n into x bar equal to sum xi. That is same as summation xi is equal to n into x bar, which is what the statement says. Let's see an example where n is 70, x bar is 25, and we want to find summation xi. As per our statement, summation xi is x bar into n, so we can calculate it as 1750. Now, further, if one observation is taken wrong, say it is 25 and wrongly taken as 52, then we want to find the correct mean. What we do, we subtract the wrong observations, add the correct observation, and again using the formula of mean, we find the corrected mean, that is summation xi corrected divided by number of observations, which is 24.61 in this case. Property 2 states that sum of deviation of observations from arithmetic mean is always equal to 0. Let's prove it. From property 1, we know that summation xi is n into x bar. Now if we take LHS of the statement summation xi minus x bar, we are going to separate out these terms. So it will be summation xi minus summation x bar. In next step, we have substituted summation x as n into x bar, and x bar here is added n times, so it will be n into x bar, and your answer comes to be 0, which is same as RHS. Let's take an example where data of marks obtained out of 10 are given of 7 students. Here your variable x summation is coming 42. First we have to find mean. So what will be the mean? It is sum of all these observations divided by total number of observations, which is 7, comes out to be 6. Now we are taking the deviation of all the values from this mean 6. So which is coming 2 minus 6, which is minus 4, 6 minus 6, 0, and so on. And its summation is coming out to be 0. So here, if we take any other example and we try to take its deviation from the mean point of the data set, your answer will always be 0 according to this property. Property 3 states that if all observations are equal, then the mean equals that common value. Proof. Let the dataset consist of n observations and each observation has same value, say p. Then in step 1 we will find mean, which is sum x upon n, and are going to substitute p here, which comes out to be p plus p so on till n times p. So n times p upon n is again coming out to be p. Let's take an example where student spends rupees 100 each day for a week. So if we want to obtain average amount spent for a week, what it will be? It will be sum of observations for the 7 days upon 7, which comes out to be 100 again. Property 4 is shift property, that is change of origin. If we add or subtract a constant from each value of variable x, then it is known as change of origin. Say if y is x plus p, then y bar will be x bar plus p. Similarly, if y is x minus p, y bar will become x bar minus p. If each observation is increased or decreased by that constant, say p, then mean also increase or decrease by p. For example, if say data set consists of 3 points, its mean comes out to be 10. Now, by adding 3 to a variable, a new variable becomes 8, 13 and 18. Y bar comes out to be 13, which is equal to 10 plus 3. 10 is nothing but our old variable mean plus 3. So here we can observe that new variable mean is equal to old variable mean plus the constant term which was added. Property 5, scale property, change of scale. If we multiply or divide a variable x by a non-zero constant, then it is called change of scale. If y is equal to p into x, then y bar will become p into x bar. Similarly, if y is equal to x upon p, then y bar is equal to x bar upon p. If each observation is multiplied or divided by constant, say p, then mean is also multiplied or divided by the same constant. For example, if we take same data set and multiply the variable with 3, we will get variable y, new variable values as 15, 30, 45, and its mean comes out to be 30, which is equal to 10 into 30. That is, old variable mean into 3 is equal to new variable mean. In property 6, let us prove and state change of origin and scale together. Arithmetic mean is affected by both change of origin and scale. We have seen it. Now, if variable x assumes n values with arithmetic mean summation xi upon n, and y is the transform variable obtained from x, which is defined as, say, a plus b into x, where capital A and small b are some constants. Then the property says that y bar is equal to a plus b into x bar. Let's prove it. We will start with left hand side, y bar, which is some y upon n. Y is substituted as a plus b xi. And next step we have separated out these two terms. So it comes to be summation a plus n plus summation b xi upon n. Here summation on constant a will become n times constant upon n plus b is removed out of the bracket and we are left with summation xi upon n. So this term comes to be capital A and this term is nothing but our x bar. Finally we get a plus b times x bar, which is equal to our right hand side. So we have shown that arithmetic mean is affected by both change of origin and scale. See an example where we have applied change of origin and scale method, which is same as step deviation method used in a previous video. Here we have taken scale interval 200, which is the difference of each wages of 5 workers, and constant is being chosen 2900, which is being chosen mostly from center part of your data set. Now we have defined a variable y, which is variable x minus a upon h, and now for each of our variable x we have transformed it into a new variable y, which gives you So if value is 2500, its difference from constant a divided by h, which is coming to be minus 2. So we have calculated it, and the transform data becomes minus 2 minus 1 0 1 2. So if we want to find mean of this transformed values, it is coming to be 0. Now we apply the property where we have shifted this h to LHS, so it will become h into y, and a is being shifted, which comes out to be plus a. So x bar is equal to a plus hy bar, and our mean comes to be 2900. That is, the mean wages of workers is rupees 2900. In this method, if you observe carefully, our values, which are very large enough, are being transformed into the smaller numbers. So it helps us for easy calculation. As Property 7, combined mean, states that if we have arithmetic means and number of items of two or more related groups in which items are expressed in same units, then we compute combined mean of groups by applying the formula. For two groups, it will be x bar c is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2, where n1 and n2 are number of observations in corresponding groups, and small n is representing total number of observations in all groups together. x1 bar, x2 bar, x bar c are representing arithmetic mean of groups and combined group. So if we prove here, we know that mean is x bar, which is summation x upon n, and then total sum of observations in group 1, what it will become, n1 into x1 bar, and in group 2 n2 into x2 bar, and total sum of observations will become sum of it, and total number of observations is n1 plus n2. So combined mean, if we substitute in the formula, it will come out to be n1 into x1 bar plus n2 into x2 bar, the whole divided by n1 plus n2. Hence it's proved. In the given example, total students in the class are 200 whose mean weight is 65 kg. The two groups are formed of boys and girls whose mean weight is 75 kg and 55 kg respectively, and we want to find number of boys and girls in the class. So given is small n, which is n1 plus n2 equal to 200. From it we have obtained n2 by shifting n1 to RHS. Combined mean of boys and mean of girls are given, and here we want to find n1 and n2. So making use of the formula of combined mean, we will substitute all the values keeping n1 n2 as it is. In next step we have shifted 200 to left hand side, and here get we have obtained n2 as 200 minus n1. In the next step we have opened this bracket, and finally we get here n1, where 75 minus 55 is taken into bracket, which comes out to be 20, plus this answer is 11,000. If we shift 11,000 to left hand side, it comes to be 100, which is equal to n1. So n2 is 200 minus n1. So we have obtained number of boys and number of girls is equal to 100. Few merits of arithmetic mean are: it is simple to calculate, it is based on all the observations, it is rigidly defined, It is suitable for further mathematical treatment and it is a representative value. Demerits or limitations of arithmetic mean. It is affected by extreme values and it is sensitive to errors in the data. It may give a value that do not exist. It is not suitable for qualitative data. It cannot be calculated accurately for open and class intervals. It does not show the distribution of data. Also, it may give misleading results when data contain incomplete information. So, these limitations of arithmetic mean can be overcome by using other methods of central tendency, which we'll discuss in the next coming video. Let's explore some applications of mean. In education, it helps to compare the performance across sections. In economics, it can help in policy making, welfare schemes. In business and industry, it will help a company to calculate average monthly sales to plan inventory. In meteorology, it helps to calculate average rainfall or temperature. In finance, it will help to calculate mean of stock prices or returns. In sport, it will measure the average runs, goals, or scores of player performance. In medicine and health, it will help to calculate average blood pressure, heart rate, which will help in health studies. In data analysis and statistics, it will be a foundation for many other statistical methods too. Here you have to quickly check whether you can identify the property in each of the questions given below. Before checking the answers on the next slide, yes, check your answers and if you have any query, you can use your comment box. Try solving a variety of conceptual application based questions by yourself. In our next video, we will study on trimmed mean, geometric mean, harmonic mean, and relation between arithmetic, geometric, and harmonic mean. Thank you for watching. Keep learning, practicing, and improving your understanding. All the best.